guys, so today we're going to be learning about the law of conservation of mass. So this law states that matter is neither created or destroyed during a chemical reaction, but thus rather the amount of matter cannot change after the reaction. So today what I'm going to demonstrate is a chemical reaction and how the law of conservation of matter is conserved. So there's a couple things we're going to be using. First weigh out some acetic acid, which is a vinegar. I'm going to place it into my bag. Doesn't necessarily matter how much you are placing into the bag because we will be weighing this on the digital scale. I like to put it in place in a corner, try to take out as much of the air as we possibly can, and then place it entirely over and onto the digital scale. I can see that, and I'm going to write down. So for my vinegar, our mass is about 14 grams. And again, there's always room for error. So I'm gonna put plus or minus about 1 gram. My point exactly. Now it's just moved to 15 grams. So let's leave it at 15 grams. Okay. The next thing I'm going to do is I'm going to be placing some of the sodium bicarbonate, which is a baking soda. I'm going to weigh that out. So what I'm going to do is I'm going to put my weighing paper onto my digital balance. It's cleared out at 0, which is what I want because this is not going to go inside my bag. I'm going to take a teaspoon or so and just place it carefully onto my weighing paper to weigh it out. Now I see that my baking soda is about 2 grams, so I'm going to write that down. And again, we want to account for any air, so plus or minus 1 gram. Now what I'm going to do is open up the bag. And as you noticed, I left some of the vinegar at the bottom. I didn't kind of disperse it all over the bag, so that way I can create like a little barrier before the chemical reaction actually takes place. So I'm going to place a little division between my vinegar and the baking soda that's going to go in the bag. I'm going to carefully, and you can have an adult help you if you want to do this at home, place it inside the bag. I'm going to take this weighing paper out. What I like to do is just make sure that all the air that I possibly can from the bag before I zip it up. I'm going to zip this up. Okay. I'm going to tear out my digital scale just to make sure it's at 0. Now the next thing I'm going to do is I'm going to shake them together. And a chemical reaction is taking place. An indicator would be that the bag is getting very cold, a change in temperature, also formation of gas. There's carbon dioxide. The bag is getting a lot more inflated. Okay. So what I'm going to do now is I'm going to place this directly onto my scale. Okay. Now, the total amount of my products after my reaction takes place is about 18 grams. So I'm going to write products equals 18 grams. Again, plus or minus about 1 gram. So again, the law of conservation of mass again states that the mass of the products in the chemical reaction must equal the mass of the actual reactants. So the reactants was a baking soda and the vinegar that we initially put into the bag. The vinegar was about 15 grams, and we had our baking soda that was about 2 grams. And if we add these two values up, we're going to get about 17 grams for our reactants. And our product, we received about 18 grams. Again, plus or minus 1 gram. And these are our products. So again, as you can see that the law of conservation of mass was shown in this example because we started out with about 17 grams of baking soda and vinegar, and we ended out with about 18 grams, give or take, so plus or minus 1 gram, so about 17 grams for the products. So again, mass is not created or destroyed, but rather conserved. So thank you for watching.